This is the decorator design pattern in Python, where the decorator design pattern is described as the Russian nested dolls, where you have a bigger doll inside a bigger doll, a smaller doll inside a smaller doll, and so you keep nesting dolls, smaller dolls, smaller dolls. You are having objects within objects within objects. That is the beauty of the decorator design pattern. Now we have this UML diagram. We know this is overwhelming, so just bear with us. We're going to be breaking this into chunks. So we have four components of the decorator design pattern. We have the component interface, we have the concrete component, the base decorator, and the concrete decorator. Now what is the component interface? The component interface is simply an abstract class. Now this abstract class is going to be shared with concrete component and your base decorator. Now both your base decorator should implement this execute, and your concrete should implement the execute function. Recall, because this is an abstract class, this execute method will be empty. Now what about the concrete component class? Now the concrete component class is your is where decorators, so these decorators are going to be wrapping. This concrete component is going to be wrapped. This is your this will be wrapped by the concrete component. Concrete decorators. Now what about the base decorator? Now the base decorator is a second abstract class. So how many abstract classes we have so far? We have one abstract class, we have a second abstract class. However, there is something special with this abstract class. We have a component, a wrapping component. This within the base decorator abstract class, we must aggregate one of these concrete components by having an object of concrete component inside the base decorator. Now this object is going to then be inherited by the concrete decorators, and so the concrete decorators will inherit from the base decorator and will extend the functionality of the execute method. So far this method is empty, this method is empty, while these two methods should have some additional implementation. Now the execute function of the decorator will be extending the functionality of the execute of the concrete component. I hope this made sense. So we have now two examples. We have one example of the big picture of the code and another one where we go into a detailed code of the UML. So let's go with the first example. So in the first example, I will be defining class coffee. And class coffee will be, this is a big picture, there is no abstract classes. So in base coffee we have a function cost that will return 5, the cost of our coffee in the coffee shop. We have another class, milk decorator. This milk will be decorating the coffee. So in it must aggregate an object of coffee. So self.coffee is equal to coffee, and don't forget to have the coffee as an attribute in your initializer. This is aggregation. And so we define the cost method. The cost method self.coffee.cost. So it will be calling the cost within the coffee and then adding additional functionality, extending the functionality. Let's create another class. So a class sugar decorator. Now in the sugar decorator, let's remove the decorator. So in the sugar decorator, we again have the same implementation. We have an initializer with with the coffee with aggregation dot coffee, same exact line, copy paste, and then we implement the cost method. So the cost, where we add additional functionality in the sugar decorator, additional functionality to the coffee, plus maybe have a 2. Okay. And this was all for the decorator design pattern. This is just a big picture, simple, just want you to understand what is going on with nesting objects. So let's start creating a coffee object. Now let's say I want coffee and something else and milk. So let's say coffee.cost right now is 5. Coffee alone is 5. I want coffee and milk. So I'll be doing coffee and milk, and then calling the milk class. So class milk and passing coffee. Now let's see the cost of the coffee and milk. Oh, so nothing is returned. So we have made a mistake. We forgot to return. So your functions should return something. So let's repeat this again. Then coffee and milk. Let's pass in coffee object. And now let's check the cost. So dot cost. Great. So we were able to successfully nest objects. Let's go nesting sugar and decorating coffee and milk with sugar. Let's pass in coffee and milk as an object. Now let's see, check the cost, and this was fantastic. And so now in this second example, we have a coffee shop which sells the three coffee types: cappuccino, espresso, and latte, charging 6 for a cappuccino, 8 for espresso, 10 for latte. When a client comes, he can add milk or almond milk to any of these coffee types. He can additionally add brown sugar and white sugar. He can decide, and we have the charges written next to each client preference. And so this is where the decorator design pattern comes in handy. So how do we approach this problem? In step one, we create recall from the UML diagram. We have the component interface. Your component interface will be the interface for your concrete classes. Your concrete classes, which are going to be wrapped, are going to be the coffee. These are going to be wrapped by milk or almond or brown sugar or white sugar. And so let's start. So in Python, from ABC, we import ABC and then an abstract method. We start by creating your concrete interface. So we have a coffee, so class coffee interface. Inherit so from ABC, and we'll have a function called cost self takes in self, and we'll pass. This is here an abstract method, and so we have the abstract method decorator, and this is done. If the coffee decides to this is done for the interface. Now let's create a class for the cappuccino. So cappuccino is going to be inheriting from the coffee interface, which is an abstract class. We'll be implementing the cost. Let's create another class for espresso. Let's create a third class for espresso, and let's create one for latte. A coffee is 6, so return 6. Espresso returns 8 as the cost, and so the cappuccino returns 6, espresso would return 8, and your latte would return 10 as the cost. And notice they are all following the coffee interface. If the shop decides to add another coffee, then he would inherit from the interface, and this will be a blueprint for future programmers. On how they can create the coffee class. Alright, so this is done. We have finished the concrete interface, we have finished the concrete classes, and so now we start with the whole milk. Notice here we have a decorator whole milk. So whole milk and almond, both of them are milk, so we need a base decorator. Brown sugar and white, so we need a base decorator. So how do we do this? Recall from the UML diagram that your base decorator aggregates one of these coffees. Let's create a base milk. So this will be our milk decorator. This will be the base milk decorator, and in the base milk decorator, recall that it will be an abstract class which inherits from the coffee interface. And why does it inherit from the coffee interface? Coffee interface is an abstract class that must implement cost. So base milk should implement cost function, so such that it adds extra functionality to the cost. In fact, we are here because we are defining the same function name in the interface, we are extending the functionality. And so it must have recall, it must have the aggregation of the coffee, self.coffee. It can be latte or cappuccino. It is many, so then we must implement the cost as an abstract. Remember, this is an abstract method. Takes in self and pass. Now we'll be creating a class for a milk. So almond, we do have whole milk and almond milk. So milk will inherit from the base milk decorator, and we'll be having def cost. When we inherit from the base milk decorator, it will automatically inherit the coffee, and so therefore it will eliminate any code duplications if we were to create another classes for other types of milks. Self, then we'll be having, now it will be calling the a cost method of the cappuccino or espresso or the latte. So this cost, so cost will be self.coffee.cost. Now the cost will be 3. So the cost of the whole milk will be 3. So so in addition to the coffee, we will be adding 3. Whatever coffee it was, we do add 3. Let's add another class. So this is almond milk, and almond milk will be having 5. Uh, so it will be calling cost inherited from the base milk decorator, and it will be adding 5. Now we have another one. So we have brown sugar and white. So because they are a common one, so we need a base decorator, an interface. So let's create a base decorator. Similar approach to the milk base decorator. So we have class base sugar decorator, which will inherit from the coffee interface. It will have the same init, and it will be having an abstract method of cost. Now we will be defining the brown sugar and white sugar. So class brown sugar will be inheriting from the base sugar decorator. Def cost to be calling upon self.coffee.cost plus 4. Let's define another class for white sugar. White sugar will be adding 2. And we're done for this code implementation. Fingers crossed, no errors. We hope we are returning. So it's very essential to return a value at your concrete classes, because these classes are going to be wrapped. These classes will be wrapped by decorators. Now the base decorator will act as a blueprint for other decorators, for future programmers when they want to add other decorators. This base decorator will be again acting as a blueprint if a future programmer wants to add another type of sugar. Let's run this. No errors. Let's now create a coffee. So we need to start by creating cappuccino. So cappuccino. Let's say you want with cappuccino, I want cappuccino and maybe white sugar and whole milk. Additional whole milk, more whole milk, be equal to whole milk. We'll be taking your coffee inside by aggregation. Then cappuccino dot whole milk dot cost would be, so we here clearly forgot to return something. Yes, we have forgot to return the cost. Apologies. Return always your classes should return a value, your method. We can start again. Cappuccino whole milk, then dot cost, we get 9. Great. Let's say we want maybe I want with whole milk, I want almond milk, or let's say I want white sugar. So white sugar will be equal to white sugar, and we'll be taking this by aggregation. Hit enter. Now let's see what is the new cost. Amazing, cost is 9, and so on and so forth. You can keep on and keep nesting your objects inside and inside. And that was all for the decorator design pattern. I hope you found this helpful, and thank you.